Simplified are a set of guys who makes it looks easy. Your number one learning channel. Ooh. Ooh.
Hello, 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 hello.
Hello, sir.
How are you doing today? It must be nice
I'm
to have
good.
electricity.
Yeah, yeah, it feels so good. Yeah,
You
yeah.
know, there's a saying which says we don't appreciate what we have until that thing is.
Mm, until it's gone.
But because I mean, in South Africa, bruh, electricity is not a big deal. Like it's
True.
like, or rather, it
Ah,
depends on, but it, we don't appreciate it that much because we're like and then that one moment, and
yes.
then it
This
just
one moment.
and the funny thing is also there's this behavior that as human species do or people as general. So you have your phone, right? And
Mm-hmm.
your phone could be going, your battery could be dying. You have all the time to can charge your phone, but
But
we
you
are
don't
those.
charge it,
Yep, we would wait for our phones to go to 1% battery flat,
and
and
then you charge it,
yeah, and the punishment happens when you are on 5%, and then load shedding happens,
and then you didn't
and
even
then you
charge the
think of
power bank. Yo,
the power bank is flat.
hey,
The and then you ask
hey,
yourself, for you, I had
yo,
all this time,
hey.
and now it's too late. Funny
Yeah, now
enough,
it's just
the way we treat our phone batteries, it's also the way we treat our finances. But you are still young, you don't understand the whole concept of saving and stuff and stuff.
yeah, not yet.
But it's the thing.
I
So
understand it.
yes, yes. Welcome, guys. Welcome, everyone. So you what's this? The way you
Electricity
treat
and
your phone
finance.
battery, the way you treat your phone battery, it's gonna be similar to So we must try to practice to
Mm.
charge our battery so we can charge our bank accounts in future. Mara, it's just that the system that we stay in the system where even finance they're just challenging generally. But
Mm.
anyway, let's pray electricity doesn't do this anymore. Let's pray because now it's exams and we need this time
Yes.
for a bit more than the time. So welcome everyone. I was just waiting for 2 or 3 people to join. It's just gonna be 3 of us in the meeting. 4 by me, so it's 3 of us in there. Right. So mm, now that we are here, most of us we've been doing mathematics when we are focusing on our alone moments. So sometimes I'll be like, just for consistency, let's always go back to the physics, come back to this, go back to the physics. So last time on the physics, we did some interesting stuff. So today, while I was preparing for this lesson, I felt the need to introduce one more last scenario of the objects when we are applying that Newton's second law. So like when an object is moving, the whole concept of using F net is equals to MA. This is what I did. I went through paper 1 of grade 10, grade 11, and grade 12. I was trying to figure out something. So the grade 10 one, not that much deep. But what I've picked up from the grade 11 and the grade 12 one is it's all about forces, acceleration, velocities that needs to be understood in order for you to get as highest marks as you can. Because at some point, we're going to talk about electrostatic or electrostatic forces. It's just that chapter on its own, which is also about a force, but now we'll be applying it using charges and stuff. That's what's happening on a question paper. And then we're going to have electric circuit, which we've been doing for so many times. It's just a matter of getting the concept right. So remember, a chapter like the one with electric circuit, the electricity chapter, it should be the one that proves to us it's not about the calculation or the question. It's about understanding the diagram. So that will be our theme for the whole next 2 or 3 months to see if we can focus on breaking down the diagram, allowing the diagram to help us get the answers. Is it going to change our marks or not? Unlike approaching the previous way of just following equations the way we want, just like that, just like that. So now, the whole thing that I'm bringing in right now is not memorizing or cramming. It's just trying to own your understanding, like telling yourself, you know what, these things I'm not claiming. I know this thing. I know it because I've sat down and I've worked different types of diagrams. I've seen different types of graphs, and I know that the approach of mathematics or any scientific related question, if there's an object provided, the core fundamental way of me getting everything that has to be asked about this diagram is if I maintain or force myself to be the same with the diagram. I don't know, like I wanted to say, when you watch too much Star Wars, you have to be one with the forces. But it's like, do you guys know Star Wars? I don't think you watch Star Wars. But 2000, I don't think you guys watch Star Wars. And besides, I have females more than I have females in this group such that I doubt if you guys watch Star Wars. But here's what I'm breaking down right now. In terms of what we're talking about for our diagram from our previous lesson, I think you still remember. I will display it if I find it. But what we said is we're going to have questions. So let's start with the first idea. The first idea, you would have a block. that is just sitting on a horizontal surface. And then that would be option 1. Option 2, you will have a block that is on an incline that has an angle. So we can call this block A, we can call this block A, that has an angle theta. And then point that this would be our second scenario. And then scenario number 3 would have a block that is on the plane, which has a force acting on it, but at that angle of theta. So another worst scenario is to look at the possibility of this. The possibility of this, it could come in a form where the incline is through the other direction, where it's still the same scenario. You have an object A that forms an angle theta there. And then from this comes every story. So this is scenario number 1, scenario number 2, scenario number 3. Scenario number 2, it applies for both this and this. So I would say this or that because it applies for both. Now, before you approach anything, you should be able to now, your eyes must be able to show you the vector diagram of each before you even do anything, regardless of what the story says on the question, but the vector diagram will assist in everything. I just want to confirm something. I'm not sure if someone is struggling with network or what, but I think someone just but anyway, in the meantime, please figure out, like, allow your mind to show you the vector diagram from your head just by looking at it like that, because this is our conclusion for now in this section. From the next one, we should approach it in a different form, but everything is similar. It's always going to be about forces, acceleration, velocity, because even whether we talk about linear motions becomes projectile motions if the motion is happening at a vertical way. So if someone throws something up or an object is moving horizontally, regardless of what happens, the equations that we use, they are always similar. Mara, I will make it make sense when we get there. So anyway, for this one, you, Mami, if you were to think of forces that are acting here, all the forces that are acting on this object, given that there is probably an applied force of some sort, and maybe I can make an applied force here as well, because here we already have one. Maybe I can make another one here, what, up or down, but it would be something like that. So obviously there's going to be friction. If there's surface is rough, there would be normal force, there would be gravitational force. So ideally, you know that your free body diagram in this scenario may be something like that, which this would be the applied force, this would be the applied force, the friction, normal force, and gravity. So you already know ideal. For this one, it will just give dimensions like that. And then for this one, ideally, you can tell, obviously you are led by your normal force. And then normal force, and then we'll have the applied force to that direction, and then we'll have the FG to this direction. Although we know that we're going to consider the angle. And for us to consider the angle, we have to construct FG perpendicular in the opposite direction of N. So if that's always the case, to get where you put your angles, you have to extract FG perpendicular to be opposite N. go acting downwards. So this would be our FG perpendicular. Now that's where your angle theta will be inside. So this angle theta will be will be where you have extended your FG perpendicular. But then to complete the triangle, obviously, you would have FG parallel this side. So you'd have FG parallel. That's how you know this triangle is necessary. But the red part is not the one that gives you the marks for the vector diagram. The one that gives you the marks for the vector diagram is the purple part. So this one is just the triangle. The triangle helps you to get your values in order. That's how it is done. So also for this one, it would be similar. You look at it based on the normal force. So the normal force would be acting to that direction, obviously. So normal force, the applied force. See now, the applied force is acting to that direction. Probably if there's friction involved, the friction would be there. Also here, if there's friction involved, the friction would be there. Frictional force. So it's just opposite the applied force. So if there's friction here, if the applied force is that direction, friction would be here, then this would be the applied force. But still, downward is your FG. And then to construct the angle in this regard, to construct the angle, you would then have to form your you'll have to complete the triangle. And to complete the triangle, you join FG perpendicular to be opposite end. So you go there towards that direction. So this would be your FG perpendicular, and then this means your angle is now formed there. But to complete the triangle, we have to complete it like that, and then we know that it's going to be our FG parallel. So that's just the story. So now, for everything that matters, is just for you to know your dimensions: horizontal motion, vertical motion, depending on what you want to calculate. If you want to calculate anything regarding N or FG, you use your vertical motion and then horizontal motion, and then we're going to use the angle to bring it up there. We've done it already, this one. I'm just finalizing the summary. So you have this one. This one is the same. It's more like a combination of this and this, but then it's just the angle only that is moving to that direction. So if we're to imagine our body diagram, normal force would be there, and then FG would be there. And then that's when the forward force will have to be affected by the triangle, because it's still going like that, and then you will have probably your friction here. So this would be your frictional force, this would be your normal force, this would be your gravitational force. But now the angle is formed here. So since the angle is formed here, and you are looking for the actual axis. So if this is perhaps F, it means this arm will be affected, because you want your F to be actually in that direction exactly, not on an angle. And then to move it from there to that, you're gonna have to use if I say cos theta is adjacent over hypotenuse. So if this is X, perhaps cos theta is gonna be adjacent X over hypotenuse F, if I use that there. Meaning, to find the value of X, it would be F times cos of theta. So meaning this line here that I'm looking for would be F cos of theta. But so far, we have done an example of this before. We have done an examples of this before so many times, but I don't think we have seen anything like this before between me and you guys, which is what I want us to do right now. I want us to look at this. Where is it? Okay, just give me a moment. Let me do the technology. It's always about the diagram. And the confidence comes from, once I know it's always about the diagram, no question forms against me shall prosper, because with even then, whatever we are moving to next, all the time. It is never really about the diagram. It is, I mean, it is never really about the wara explanation. Confidence comes from I understood the diagram, I owned the diagram, I've seen the information that is needed from the diagram. Uh, right. I don't think, remember, the goal is we are not worried about definitions and get for now. Thing is, with definitions, we know how to work our way out around definitions, because I feel like you can even memorize the night before. But without memorizing also, it's nice to know by understanding what really is going on. But no pressure for now. I'm still gonna find a way to explain if should I. Mara, with definitions also, it's not about memorizing exactly how it's given. It's also about being able to explain the definition to your 7-year-old younger brother or your 7-year-old younger sister. If you are able to do that, then that's how I know you understand the definition. But also, some of these things we talk about them in our one-on-one lessons. So definitions are not really that much of a big deal. Here we have a box with a mass of 45 kg. It's pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity, which is in capital letters. And the moment you see constant velocity, something must come to your mind. And that one thing that comes to your mind, believing in your mind, or when velocity is constant, there's something happening with something. Anyone who remembers what does constant velocity mean?
Acceleration is zero.
Acceleration is zero. And remember, we have proved it. Why? Is there anyone who knows why or who doesn't know why acceleration is zero when velocity is constant?
Mm.
Huh? You all remember, ne? You all remember how can we prove? Because when velocity is constant, it means it is not changing. That's what, uh, let me look for my electrical pen. I thought I'll have to search. It was not that. So, for this, for constant velocity, you keep in your mind where acceleration is change in velocity over the change in time. That's the basic standard way of calculating acceleration. Any other equation that comes after, it was derived from this. This is the original calculating acceleration. I even showed some of you where the very same equation is the one that gives birth to those equations of motion, which we end up having vi is equals to vu plus a change in t. That formula is derived from this formula. It's just that we don't have to prove it now, but I'm just saying it is like that. And because of that, we know that acceleration, since it is change is saying acceleration is final velocity minus initial velocity over change in time. So since the top part says final minus initial, when velocity is constant on each and every point, if on point A, point B, point C, and point D, when the object moves throughout, the velocity has been 2 meters per second, 2 meters per second, 2 meters per second, 2 meters per second. It means it is constant throughout. Meaning, if you take the final velocity and you subtract the initial velocity wherever throughout the whole point, you will end up you'll always have a zero because you'll have a 2 multiplying by 2 over change in t. So as long as the velocity is the same throughout, final velocity and initial velocity are now equal, which makes it to be zero. So every time you calculate acceleration throughout a scenario where the velocity doesn't change, it makes the acceleration to be zero every time. So mathematically, this is how you can explain it if you were to prove it. But also, in reality, it just makes sense like that. Accelerating, for those of you who are driving, accelerating, when you press that pedal, you are saying, I am accelerating. So now you are increasing the velocity. That's the definition of acceleration, because it's changing velocity over the changing time. So when you press the pedal, you are increasing the velocity. When you press your brakes, you are reducing the velocity, which result in acceleration happening, because it is the change in velocity as time changes. So velocity and acceleration, they are more like dependent on one another, because without velocity, there wouldn't be acceleration in a way. It makes sense, ne?
Yes. Yes.
Great. Now, are you able to picture the free body diagram of the scenario that you have here? Anyway, this one should be not that difficult. Hence, I'm saying the most important one about this, I was just fascinated when I saw question 3.4 and 3.5. That was the reason why I selected this topic just for today, Jay. To conclude on those, on the object like this, where sometimes we talk about Newton's second law or first law. 3.2. Okay, 3.1. Define the term kinetic frictional force. I'm not worried about the definitions since I said, excuse me, I'm not worried about the definition, like I said, but just to save your life from this, you would say kinetic frictional force is the force that opposes the motion of a moving object relative to a surface. Kinetic frictional force is the force that opposes the motion of a moving object relative to a surface. Which surface? The surface that the object is moving on top of. So relative to this surface. So if this is the surface and the force is going to that direction, kinetic frictional force is the force that opposes the motion of that object while the object is moving in a surface or relative to a surface. That's just that. So you are not defining it by memorizing, you are defining it by understanding what is going on there. Secondly, state Newton's first law of motion in waves. Newton's first law of motion in waves, the best way to remember it is to know that the Newton's first law is the same as the law of inertia. The law of inertia, the best example to the law of inertia is that one where if you are sitting in your parents' car at the back and they are driving, and then all of a sudden the traffic light turns red, and then they hit the brake so fast, and then you hit your head on the back seat of their seat because you were still moving in that velocity of the car before they hit them so fast. So you continued with the velocity until your head hit there. That's the best scenario to can explain inertia. But Newton's first law is the law of inertia. So it explains exactly that, Corey. Your body will remain in a state of rest or at a constant velocity that you were moving on the entire time when you were sitting at the back of the car, unless a non-zero resultant force acts on it. When they break, now they are forcing you to be out of the motion. Again, I've seen you memorize these things. 2 marks, not a problem. Let's go to real stuff. Real stuff is, number one, we have to calculate the magnitude of the horizontal component of the applied force. Now, why do you think they brought up components here? Let's look at our vector diagram. Remember, it's not about the question, it's about the diagram. So let's go there. In our diagram, the way I've showed previously, we had our normal force according to this. We have our frictional force, kinetic friction. We have our weight, mg. And then we have our normal force 90 degrees. But this normal force, it's at an angle 50 degrees. But to complete the triangle, we still have to have that side there. We can't run away from it. So it takes us back to when we started with our vectors and we're doing those components. And you thought it's about vectors only. Because at the end of the day, if I want to calculate, okay, let me do this. Let me also label these sides. So we all know that this will be N, not F. Since they named that force N, I can name my normal force something else. Since they named this force N, let me name my normal force small letter n, just to differentiate the variables, because it's going to seem like I'm saying normal force is coming to the other side. So let me name this just small letter n, but it still represents normal force. So if I name these sides, I know that these sides, it's going to be n. This side is going to be n cos 50. This side is going to be n cos 50. And we know that this side is going to be n sine 50. Are we still together?
Yes.
Now, one of the main important punchline of these lessons is you should be able to know F net for Y component or for Y, F net for vertical axis, as well as F net for horizontal axis. Now, here's the thing. I always say, whenever someone says F net, you guys know that F net is equals to MA. But also on a vertical axis, also F net could be equals to mg. But it's just that the G stands for the acceleration, which is, but let me not go there for now. I don't want to confuse you a lot. But I've said it's not really about this part. I understand, and I know that a lot of you may feel like I'm confusing you at the moment, Mara. I will land eventually. Let me land with whatever I want to say. The whole concept of FNet is not about the left-hand side of MA. The whole concept of FNet is about this side. It's where you are able to add your applied force minus W plus what plus what to cover up this part. Because the MA part is not so important. It's just about the mass of the object and the acceleration of the object. You can never go wrong in substituting on the left-hand side, on the right-hand side, I mean. But on the left-hand side, to get this F net is so important. So what I'm saying is you must always tell yourself, Puri, let me do this F net aside. Let me try to see the F net aside. So I want to see F net for the X net for the X intercept. In this regard, it would be equals to the forward force, which is what? I'm going to ask in one of you. Which is N cos 50 minus FK. So that's the F net for the X component. Do you get that?
Yes.
But now we still have F net for the y component. Why does it matter this time around? Because normally, if we are not pulling that thing out at an angle, we know that normal force is equals to mg. But this time around, suppose I take downwards as positive, and I know that normal force is equals to mg. Since I know that normal force is equal to mg, it's already satisfying. But F net, let me write it underneath there. F net for y, it's gonna be, I can choose if I wanna let up to be positive or I wanna let down to be thingy. But this one is straightforward. It's not jigga-jigging. It's not like with the weight is directly. So whether I call it weight or I call it FG, doesn't matter. Other people prefer to call it FG. So let me call it FG, force of gravity. But it is the weight, FG. So then in this regard, if there was no angle, F net by the y-axis was just gonna be FG. But because we have another new component that was formed by that angle, we can't ignore it. Same as we did when we were doing vectors in the first chapter when we were just starting early this year. We can't ignore that part. It falls under what is happening. It falls under the components. So the F net for the y component is going to be minus n sine 50 degree. So it will be F net for y is Fg, because I'm choosing downward to be positive, and the upward one will be negative because it's acting to the different direction. Also, F net for x is going to be the forward force, which is n cos 50 minus Fk, because Fk is kinetic frictional force, and we just defined that kinetic frictional force must act to the opposite instead of going to the actual direction. We're still together, né?
Yes.
From this, you guys can answer any question that comes after. Why? Because you have a lot of information. Now, let's calculate the magnitude of the normal force. I want you guys to first try it, and then we're gonna compare our values together. I will also do it here, but I just want you to try it on the side, and then we see. Oh, no. We still haven't calculated 3 we're still on 3.3. We need the magnitude of the horizontal thingy. This one I will assist because it's just 2 marks. I want you guys to try 3.4 actually. 3.4 and 3.4 and 3.5. So this one we can go with it together. Let me just erase this now. So we are looking from, remember, it's all about the diagram. Let's go to our diagram. In our diagram, we can see for the horizontal component, calculate the magnitude of the horizontal component of the applied force. So they don't need F net of the horizontal component. They don't need F net. Only need of the applied force only. The horizontal component of the applied force only. So they don't, since they don't need F net, we're not gonna include Fk. They only need the force that acts in that direction. So to get that, we would say F of x component is going to be equals to n cos of 50 degrees. But you know, this story starts from cos of 50 degrees is equals to adjacent fx over hypotenuse n. And then what they did there, they cross multiplied. They cross multiplied because any number is over 1 in order to get to the second step. But anyway, I know that most students just copy from the second step, but I'm just saying the nature of where it comes from. So it's just 2 marks. You just substitute your things. So that would be 90 newtons cos of 50. Actually, that force, they never named the force N. I don't know why did I think it was named N. It's just 90 newtons. So the N is for the SI unit. but it doesn't affect anything of what I've said so far, so it's okay. Therefore, this would be, if you use a calculator, we should be getting 57.85 newtons. Or closer to this. So, again, you just went through the diagram of the thingy that you have to get that. And everything that we do, it will be about that diagram at the end of the day. Now, you are required to calculate the magnitude of the normal force. The magnitude of the normal force. Now, the normal force is on our vertical component. So, to get that, that's why I said it's important to know both your F net of the horizontal component and your F net of the vertical component, because it's all about you being able to break down the F net part. So, for the normal force, still, the vertical motion is not moving such that the net force of the Y component is equals to 0 anyway, because that thing is not moving vertically, it's just moving forward and back. But although it's moving on constant velocity, even the forward and back, even the forward motion is still F net is 0 anyway, because acceleration is 0. We've said that when the question starts, but also the vertical one is just like that. And because of that, if now I am to calculate, the I have to include that component somehow from my, so as much as the F net is 0 on that part, I think because of the angle, it is affecting something, such that that component, let me call it Fy component. Fy component is going to be Fg minus n sine 50 degrees. Let me stop here and ask, does everybody else understand why I'm putting it like this? If there was no component, you were just gonna say Fg is equal, you were just gonna say the y, the component Fy, it was just gonna be Fg, because Fg and n would then be equal. So just by calculating Fg, you have got the value of the normal force. But this time around, we know that we have to somehow include the Fg there. So since I'm calculating normal force, I can just name it n. So n is going to be equals to Fg minus thingy. Mara, just to make it make sense, it's from the fact that all the forces that are acting vertical, they are 0. So if I was to add that, I would say Fg minus n sine 50 minus normal force, which is small letter n, since I've named that force n, is equals to 0. So basically, I just applied F net, and then I broke down the forces the way I know, the way I'm saying, allow the diagram to work for you. So Fg acting downwards minus n sine 50, that component there acting upwards, minus n, that normal force acting upwards is equals to 0 because the diagram is not moving to anywhere. So the reason why the formula ends up like this is because I just took the n to the other side because I'm solving for n. Hence, that n now becomes fg minus n sine 50 degrees because I'm solving it. Does it make sense to everyone, this part?
Yes.
Perfect. If you are missing something, text me on WhatsApp. Don't allow me to proceed because we'll forget we're talking about this. Even when we do one-on-one, we'll forget what we talked about this at some point. So unless you write it down, you'll ask me in future. It's okay also. So here would have mg minus 90 degrees sine of 50. Mg, our mass is 45. G is 9,8 minus 90 degrees sine of 50. Therefore, there goes our value of n. N will be N1 with the value. You guys are not next to your calculators, ne?
Yes.
Okay. Next time you must be next to your calculator. So if I punch it, it would be
372.6.
sure. 372.06 Newton. And it's not about the final answer. We all know it's not about the final answer. The final answer is just a brag, but it's about the diagram, interpreting the diagram. So you see, normally for you, you would look for it from here. And it's not even from here. It all starts from F net is equals to MA. It was supposed to be MA, but since the acceleration is 0, F net is 0. So since F net is 0, the most important part, guys, is for you to be able to outline all the forces that represents F net. And I've been saying so from our previous lesson. And this thing, it takes practice, bruh. Because it's not like a quadratic function whereby if you know how to complete a square, you'll always have 3 terms, ax squared plus bx plus c. This one, the net force, you can't predict the net force. Sometimes you're going to have 4 forces as part of your net force. Sometimes you're going to have 3 forces, sometimes 2, sometimes even 1. But to determine how many forces are acting to be part of the net forces, that information is from the diagram. The diagram. It is about the diagram. So without having a perfect diagram, you would never, ever, ever be able to articulate this part properly. And once you fail to articulate this part properly, it affects your answer. And once it affects your answer, it will affect any other thing that come after. But some questions, they require the previous answer that you got from the previous question to be applied on the next answer for you to continue getting marks. So we know that's the beauty of maths. So every time when you are practicing physics, every time, whatever topic it may be, look at the diagram, focus on the diagram, own the diagram. By owning the diagram is to search for as much information as you can before you even attempt the question regarding that diagram. Put the diagram on the side, and to get the confidence in all this, it just requires different types of practice. So you're gonna approach maybe 5 different past papers. you look for diagram that looks like this in all the 5 papers, questions that are similar to this question, and then you go through them. But you focus on it's about the diagram, and then you see if all the answers won't come out. If none of the answers comes out while you are focusing on the diagram, you're gonna send the question to me. We'll break it down together to see whether was the diagram correct or not. Because in most cases, for you to feel like you are getting wrong things is because the diagram would be wrong in that case. So that's the story of the diagram. Calculate the coefficient of kinetic friction for this question. Guys, I think by now you know that both kinetic friction and static friction, we calculate them similar, more or less the same way, right? Actually, kinetic friction, it's kinetic friction itself. Basically, we have these formulas. Kinetic friction you multiply it by normal force with the coefficient to get the kinetic friction. So the coefficient may be given in most cases to get the kinetic friction. But in this regard, for us to get the kinetic friction, it means then for the coefficient, it means then the coefficient is supposed to be the kinetic friction divided by the normal force. Now, we are not worried because we already have the normal force. Here is our normal force. Our normal force is 372.06 Newton. Hence, I say the previous question may be applicable to the next question. But we don't have our friction. How do we do that? Because in order to get the coefficient UK, we need FK, the fractional force. How do you think we can get that? Any suggestion? And I know, Hore, you might feel like, Ish, if I say it, what if? But whatever you are thinking of is the correct one. To calculate the FK, we can't do anything else without going back to Fnet again, because it is about Fnet is equals to MA, remember? So Fnet, where the friction is Fnet of Y component. We did say that the Fnet of the Y component is equals to N cos 50 minus FK. And you know that this is equals to MA. But this time around, because the acceleration, because the velocity is constant, this is equals to 0. Meaning N cos 50 degrees minus FK is equals to 0. Meaning FK is equals to N cos of 50 degrees. This means that what's this? Your acceleration will be, please calculate for us, Kanya. Oh, we did calculate this on number 1. Remember we got the FX component, which was just that part only. We did calculate this. It was 57.85. And it makes sense because the net force is 0. So if the net force is 0, it means the force acting forward will be equal to the force acting backward. And then the question was to get the coefficient of friction. So now here's your formula. UK is equals to FK over N. And you know your FK is 57,85. And you know your N is 372,60. So there goes our coefficient. Then our coefficient is gonna be we depend on the calculator holder.
Oh, sorry. 0.16.
0,16. There we go. 0,16. The coefficient doesn't have an SI unit. So you just 0,16 like that. Some questions, they need a bit of application of your thoughts. Will the coefficient of kinetic friction change if the angle of the applied force is decreased?
No.
Why not?
Um.
Because the coefficient is dependent on the surface, this surface here. So just by changing the angle, it doesn't change this surface, because this surface is the one that affects the coefficient. Because we're going to have the coefficient, it's about, remember, when we define kinetic friction, we said it is the opposite force that act, it is the force that acts opposite to the normal force relative to the surface, because it's the surface of the between the object and the thing. So because of this, so the answer is no, you are correct. So the coefficient is dependent on the nature of the surface, not the changes of the angle or the type of material that is the object is in contact with. That's what the surface is all about. Anne?
Yes.
Okay. I'm not sure how you guys are feeling, or are you are tired or not. Let's take some 10 minutes break. I will send another link for us to do the math, because today I started work very late, so I'm just trying to improvise, or at least we sleep knowing we've done something, because consistency help us to, we don't know what's going to happen tomorrow. So the more, whenever we get time, we cover something up, it helps us in many ways. So you see, for a lesson like this, we never planned to go as detailed with some of the stuff. Hence I say, my worry is when I do one-on-one lesson and I go as deeper as a lesson like this, it ends up worries me where I might not have the same energy for the next student the way I had with this student, because like as time goes, you like morning lessons, that's when you're like, ah. But the moment is like this time, you're like, yo, man, I've been waking since 2 p.m. Like, yo. So sometimes I'm gonna make sure around this time, that's when we learn important stuff. That's when we are like 2, 3, 4, 5 young of us. And then early, when you come back from school early, or for those whom we are able to talk during the day, that's when we focus on all the questions you have properly. So I'm gonna formalize this time to be mainly about teaching. It's not about write it down and send me a picture all the time. The write it down, send me a picture, it's for us, because I care about the way you present your work. But real learning happens when you are just listening, and then maybe you write your question down and then you save them for the private part. I mean the private lessons part, sorry. Now we can log out from here. Like you can I'll send the thing now. Let me just prepare for the math. Thank you. We'll talk soon for those who will be available. No pressure. No pressure. All right. So for those who are watching from YouTube, this is what we do. We offer private lessons at a very reasonable fee. And like I say, we don't go with this thing of give us this amount of money for an hour. We just teach you a child, or you as a student, if you are listening as a student, we just learn throughout the time. No limitation of lessons, just until you are able to understand and unlock your knowledge, so you'll do well in your mathematics and physics, because we are mainly big on maths and physics. Though we have other subjects which other people are assisting with, but here in this room, it's about maths, physics, high school, grade 8 to grade 12, maths and physics, even natural science for those who call it that when you are still lower, and also university students sometimes. But yeah, to join our lesson, you can either subscribe, press the reminder button for every time we go live, but also to join our private lesson, you can to join our private lessons, you can send you can send a message to this number 081 465 2676. That's 081 465 2676. And we are here for you throughout the time. Simplified RSA, the guys who make it look easy. Thank you.
Simplified RSA, the guys who makes it looks easy. Your number one learning channel.